Today I discuss about group and some examples. So what is a group? Definition of group. If we take a set G, this is a set G and a binary operation, say omicron, in such a way that it satisfies some properties first property is closure property. If we take the set G with elements A, B, C, a finite set, then A omicron B also belongs to set G. Since A belongs to G, B belongs to G, with respect to this binary operation, A omicron B belongs to G. In same way, A omicron C belongs to G and B omicron C belongs to G. So this property is called closure property. If this is satisfied, then another property is associative property. Here we take the three elements A omicron under bracket B omicron C is equal to under bracket A omicron B omicron C. So this is called associative property. We can take this in this way also. B omicron A omicron C is equal to under bracket B omicron A omicron C, or we can take C omicron B omicron A is equal to under bracket C omicron B omicron A. So if this is satisfied, this property is called associative property. So these two properties with another property of identity element. So we have A omicron B is equal to B omicron A is equal to A, or A omicron C is equal to C omicron A is equal to A. Then we will say that here we'll take actually B, and here we will take C. Then we will say that A, here A is the left identity element, and here A is called right identity element. If both the elements are same, then we commonly say that element. If both the element, left identity element and right identity element are same, then we will say that A is the identity element. Now, the fourth property is the inverse element property. Here we will take, since A is the identity element, A uniform B equal to B uniform A, or we will take in this way B uniform C equal to C uniform B equal to the identity element A. Then we will say that B is the inverse element of C, or C is the inverse element of B. B is the inverse element of C, or C is the inverse element of B. So there are four properties: closure property, associative property, identity element, and inverse element property. So if this fourth property is satisfied, then we will say that the set G forms a group G under first bracket with the binary operation unequal, builds a group. So this set G with respect to this binary operation unequal is called a group. Now another property, this is the special property, commutative property. Here B omicron C equal to C omicron B. If this happens, then we say that here we actually write down that omicron B is equal to B, and this is written B omicron A is equal to B. A omicron C is equal to C and C omicron A is equal to C. So here B A is the identity element, left identity element, and here E is the right identity element. Here E is the left identity element, and here E is the right identity element. Here also we have to change the B omicron C is equal to A and C omicron B is equal to A. So here B is the left inverse element of C and C is the right inverse element of B. Here C is the left inverse element of B and B is the right inverse element of C. Now the commutative property tells that if B omicron C is equal to C omicron B, then G satisfies commutative. G is commutative or G satisfies commutative property. So in this case, we will say that this group G omicron, the binary operation G omicron, the set G with respect to this binary operation is an abelian group. Now we will take an example. Let's take the set S, the set G is X such that X belongs to integers. X belongs to integers. And the omicron is we will take addition. Then we will verify that C G with respect to this binary operation addition forms in group or not. So first set is first verify it is closed or not. So closure property we will first verify. So if we take any number phi which belongs to G and minus 6 which also belongs to G, then phi plus minus 6 which is equal to minus 1 it also belongs to G. So if we take another also example, then we will find out that with respect to addition G is closed. So here G is closed. So it satisfied closure property. Now associative property. If we take 5 plus 6 plus minus 2, we will have 5 plus 6, 11, minus 2 is equal to 9. And if we take 5 plus under bracket 6 plus minus 2, it will be 6 minus 2 is equal to 4 plus 5 is equal to 9. So in this way, if we verify another example, taking another element from the set G, we will find out that G is associative. G is associative. So the second property it satisfies. Now the third property, this is identity element. We will take 5 plus minus 5, we will get 0. In this way 7 plus minus 7 is equal to 0. If we will take minus 5 plus 5, this is also equal to 0. If we take minus 7 plus 7 is also equal to 0. So here 5 is the 0 is the identity element. 0 is the identity element. So we have an identity element in G. 0 is the identity element belongs to G. Now the fourth property, inverse element property. We have taken inverse element. This is actually not identity. This is the inverse element. We have to now again check this. Actually, if we take 5 plus 0, we will get 5. 6 plus 0 is equal to 6. If we will take 0 plus 5, we will get 5. See here, 0 is the right identity element, that 0 is the left identity element. Both are equal. So 0 is the identity element of the set G. Now inverse element, if we take this example again, 5 plus minus 5 is equal to 0, where minus 5 plus 5 is equal to 0. Here 5 is the left inverse of minus 5, and here 5 is the right inverse of 5. Or in another word, minus 5 is the right inverse of 5, or minus 5 is the left inverse of 5. So there exist inverse elements. 5 is the inverse element of minus 5. So inverse element also exists. So these four properties, closure property, associative property, identity element property, inverse element property, all are satisfied by the set of integers. So you say that G with respect to this binding operation addition builds a group. Now we will also look this that 5 plus 6 is equal to 6 plus 5 for all elements in the set B, in the set G. So we can very easily say that it is abelian also, commutative also. G is commutative, the set of integers is commutative. So G is also builds an abelian group also. So G will be an abelian group or a commutative group.